Hi dear students, good evening. Today we are going to discuss another section of differential equation, that is Leguerre differential equation, right? So previous class we have seen what is Hermite differential equation. It is a higher order differential equation, right? We solved using series method of solution of differential equation, right? Here we discuss with the Legurre polynomial. It is another kind of higher order differential equation. So first of all we can see what is a Legurre differential equation, right? So Legurre differential equation is, it is in the format x d square by dx square plus 1 minus x into dy by dx plus ny, where n is an integer. N may vary from 1 to infinity, 1, 2, 3, 4, 5, etc. Right? So based on the n value, the property of Legurre differential equation solution will change, right? So that and all we will discuss. So before that, x d square y by dx square plus 1 minus x into dy by dx plus ny. To solve higher order differential equation, what we have observed, we have seen the series method of solution, right? What we have to assume first y is equal to sigma n is equal to 1 to infinity a n x raised to n, right? A n x raised to n. This is the solution, right? We assume this is the solution. Then what we do? Then we find dy by dx from it, right? Then d square y by dx square, then we substitute that values here and then we get an equation. Then by solving that we will get the final solution, alright. So that is the method of a series solution, right? That means series solution means put n is equal to 1, 2, so we can a1 x raised to 1 plus a2 x raised to 2 plus a3 x raised to 3. Okay, so like that it's solution varying, right? So we get an infinite member, right, in the expression of y, right? So that is the method. Now, so we are not going to solve this. So this is the method, right? So what is the solution? Solution is, see, so by putting the y value, right, sigma n is equal to 0 to infinity a n x raised to n. Finally, we solve the solution of this Legurre differential equation as ln of x is equal to sigma r is equal to 0 to n minus 1 raised to r n factorial n minus r factorial whole raised to r factorial square x raised to r, right? This is the solution, right? But we have to see what is L0 of x, what is L1 of x, L2 of x, etc. That value we required for solving different kind of problem. So let us see what is L0 of x. So L0 of x is equal to, L0 of x means n is equal to, you put 1 here, sorry 0 here, L0 of x. Then sigma r is equal to 0 to n is equal to r is equal to 0 to 0. That means only one value. R is receiving, n is already 0. L0 of x means you can put n is 0, right? And r also, r value also varying from 0 to 0 means only 0 value, right? That means minus 1 raised to 0, 0 factorial divided by 0 minus 0 whole factorial into 0 factorial whole square into x raised to 0. Definitely it is 1 only, right? 0 factorial 1 minus 1 raised to 0, 1, and by substituting all the values, right? So this and all 1, then 1 only. So L0 of x is equal to what? 1, right? Now L1 of x, what is that? Right? So let us find L1 of x, right? So L1 of x is equal to, that time put n is equal to 1. First you write sigma r is equal to 0 to 1, put n is equal to 1 here. L1 means this L1 of x means n is equal to 1. Then minus 1 raised to r 1 factorial, that is 1 divided by 1 minus r factorial, right, plus r factorial again, right, r factorial square into x raised to r, right. Now r is equal to 0 to 1 means first you take r is equal to 1, right. R is equal to, first you take r you can take as 0, then we can take as 1, right. Then minus 1 raised to 0, right, x raised to 0, right, 1 minus 0 whole factorial and r factorial whole square, that is again r is first 0, right, 0 factorial whole square and x raised to 0, right, plus next value is what, r is equal to 0 we put, now r is equal to 1, that means minus 1 raised to 1 x raised to 1 divided by here 1 minus 1 whole factorial and 1 factorial whole square, right. Now by substituting all this value, what I can write, that means here it is 0 factorial 1, 1 minus 0 factorial 1, this 1, 1, then 1 plus, right. Now here what, minus 1, right, x raised to 1, then minus x, here 1, then minus x, then what is L1 of x you can write as minus x plus 1, right, minus x plus 1, alright. Now, so by solving first L0 of x you are getting 1, L1 of x you are getting minus x plus 1. Similarly, put n is equal to 2, then r can receive 0, 1, 2. By substituting all that value, finally you get a L2 of x also. Similarly, we can find L3 of x, L4 of x, up to L3, L0, L1, L2. These values, first 3 value you should by heart, right. If any above L6 something ask means, we can put in this equation and we can find, right. Alright, that is the method. Now, here I shown some value, L0x we solved, we get 1, and L1 of x we solved, that we go to minus x plus 1, and L2 of x is 1 by 2 into x square minus 4x plus 2, and so on, right, up to L5 I mentioned here, right. So, up to this you have to by heart, L0 of x value, L1 of x value, L2 of x value, alright. And if L4 value for an examination, L4 is asking means you have to put that is summation of r is equal to 0 to n is equal to 4, right, alright. Now let us go to graphical representation. How we can represent Legurre polynomial. Actually, what is Legurre polynomial? Legurre polynomial is the solution of Legurre differential equation, alright, alright. So Legurre polynomial, so what we have seen, L0 of x, let us check, L0 of x we have seen, L0 of x we have seen 1, L1 of x we have seen minus x plus 1, L2 of x we have seen 1 by 2 into x square minus 4x plus 2 and so on, right, like that we have seen, right, alright. Now L0 of x is equal to 1 means it is a constant. See here, suppose here I am plotting Legurre polynomial value, right, and with respect to x, right, x variation. Now see suppose L1 of x, that means here, right, 1, see Legurre polynomial value is 1, right. So L0 of x is equal to 1. So this line represents L0 of x, right. That means that value is 1, alright. Now L1 of x is equal to minus x plus 1. Minus x plus 1, minus x plus 1 graph is how? Minus x plus is mx plus c format is a straight line, but the slope m is equal to minus 1, alright. So this is the graph, see, this is straight line but a negative slope, this is this second, right. Now L2 of x is, look here, that is a quadratic polynomial. Quadratic polynomial is parabola, see, this graph representing this is L2 of x. Now L3 of x is a cubic polynomial, right? So this cubic polynomial like this, right? So and so on. So graphically we can represent it based on the nature of the degree, right? Alright. So that all about a graph, right? Now next is generating function, right? Generating function means actually it is very difficult to solve. So we derived a solution as summation of series, right? So suppose L10 of x asking means it is very tedious to find, right? So to find this L1 of x, L2 of x, L3 of x and higher values of Legurre polynomials, we can use this generating function. Alright, what is generating function? Suppose this is the generating function, right? We can prove that, see, suppose this is the generating function, that is e raised to minus xt by 1 minus t divided by 1 minus t. You expand this, right? You know exponential series, right? E raised to x, how we expand 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. Right? Alright. Now by expansion of this function e raised to minus xt by 1 minus t divided by 1 minus t, right? Then what we can say in the expansion, right? In the expansion of this, coefficient of t raised to n you can take as ln of x. Then in first you expand this, right? Then coefficient of t raised to 0 you find means what you get? L0 of x. Coefficient of t raised to 1 you find means what you get? L1 of x, right? And coefficient of t cube you find means you get L3 of x, right? That is the method. So let us see. So we can expand this function, right? So let us see the expansion. See, look here. This is the function which I mentioned, right? This is the function which I mentioned, alright? So what is 1 by 1 minus t? 1 by 1 minus t I taken out. From this 1 by 1 minus t I taken out, alright? 1 by 1 minus t taken out. Remaining e raised to minus xt by 1 minus t. That I expanded using 1 plus, see, e raised to x differentiation is e raised to x series expansion is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. Right. So instead of x what we have given minus xt by 1 minus t. Then 1 by 1 minus st into 1 by 1 minus t into 1 minus plus x is minus xt by 1 minus t plus 1 by 2 into square of this part, that is x square t square by 1 minus t square into 2 factorial is 2 and again 3 factorial is 6, but this minus xt by 1 minus t whole cube, that is x cube t cube by 1 minus t cube 1 minus t whole cube, right, plus etc. So expanded like this. Then multiply here 1 by 1 minus t minus multiplying this is xt into 1 minus t square plus by multiplying this and this term, right, this and this term x square t square by 2 into 1 minus t cube and multiplying this x cube t cube by 6 into 1 minus t raised to 4. Alright, this is not t raised to 4, 1 minus t all raised to 4, right? Alright. Now this is what take to numerator 1 minus t all raised to minus 1 minus xt into this take to numerator, that is 1 minus t all raised to minus 2. Here x square t square by 2 into this go to numerator, that is 1 minus t raised to minus 3. Now expand using this formula. 1 plus x all raised to n is what? 1 plus nx plus n into n minus 1 into 1 into 2 into x square plus n into n minus 1 into n minus 2 divided by 1 into 2 into 3 into x cube plus etc. Right. Alright. So instead of 1 plus, this is 1 plus x whole raised to n. So this is 1 plus x whole raised to n formatted by expanding 1 plus t square plus t cube plus etc. here minus xt I taken out, 1 minus t all raised to minus 2, 1 plus 2t plus 3t square plus 4t cube plus etc. Right. Put here in this equation, put a x is minus t. Right. To expand this, put x minus t here and this minus 2 here. Right. Minus 2. Then plus 2t. Right. 1 plus 2t. Alright. So next term is put n is equal to n value and t value, then you get the correct value. Right. Yes. Then 1 plus 2t 3t square plus 4t cube. Next term is x square t square by 2 into 1 minus t all raised to minus 3. Then 1 plus 3t plus 6t square plus etc. Alright. Alright. Now the problem is, what is L0 of x? What I told you, L0 of x, coefficient of t raised to n. Then coefficient of t raised to 0. Coefficient of t raised to 0 is L0 of x. See, here t, here t, here t, here t, all term having t. Then t raised to 0 coefficient what? T raised to 0 means 1. Then t raised to 0 coefficient is 1. Then L0 of x is equal to 1. Alright. Now L1 of x I can find. Coefficient of t raised to 1. Coefficient of t raised to 1. What is t raised to 1? T raised to 1 coefficient is here 1 and this term coefficient of t multiplying by this to this coefficient of t is minus x. Minus x. Then minus x plus 1. Am I right? So we have already studied L0 of x is 1. L1 of x is minus x plus 1. Now it is true, right? Now similarly what we have studied L3 of x we have studied as, right, L2 of x we have studied as 1 by 2 into x square minus 4x plus 2. That also you can prove from this, right? So what is L2 of x, right? See, we can substitute. So that means coefficient of L2 of x is coefficient of t square. Coefficient of t square means here you get a coefficient of t square 1. Alright. So we can take a 1. Now what is coefficient of t square here? Here t into t square, then minus 2x. Here you have a minus 2x. Alright. Now here a coefficient of t square what? X square by 2. Right. Multiplying with 1. Then plus x square by 2. Now you can take 1 by 2 out. 1 by 2 you take out means what you can write, x square minus 4x plus 2. Right? Then this value also correct. Right? So similarly we can find from this this formula, generating function, expansion of generating function, then coefficient of t raised to n you can take as ln of x. Alright? Alright. Now let us go to another part. Alright? Yes, so this is the generating function. Alright? Now next is Rodriguez formula. Right? In Hermite polynomials also we find a Rodriguez formula. This is also one of the easiest method to find L1 of x, L2 of x, L3 of x. For example, to find L0 of x, so let me take a pen. To find L0 of x, right, put n is equal to 0 here. E raised to, what is ln of x? As Rodriguez formula state that ln of x is equal to e raised to x by n factorial, d raised to n, dx raised to n, x raised to n, e raised to minus x, right? So e raised to x into L0 of x means 0 factorial into d raised to 0, dx raised to 0. That means no differentiation. D raised to 0 by dx raised to 0 means 0 differential order, right? That is x raised to 0, e raised to minus x. Now here e raised to x, here e raised to minus x only. What is 1? Then L0 of x is 1. It is correct, right? Now L1 of x you can find, you can verify this. E raised to x divided by 1 factorial into d by d x raised to n into x e raised to minus x, right? Then e raised to x into by product rule differentiate. N is equal to 1 because we are finding L1 of x, right? So what first function into differential of second function minus e raised to minus x plus second function into differential of first, right? Then e raised to x into e raised to minus x, right? That is 1, then minus x. Now e raised to x into e raised to minus x, then plus 1. See, minus x plus 1. Alright. So we have already seen L1 of x is minus x plus 1. We have already seen L0 of x, that is 1. So this formula also. Now to find L2 of x, you can find a triple differentiation. But in higher order, suppose fourth differential and all coming, this will be, the calculation is much tedious, right? But this formula is valid, right? Alright. Next, see orthogonality relation. Orthogonality relation also we seen in Hermite polynomial also, right? So orthogonality relation. Next, see integral 0 to infinity e raised to minus x ln of x into lm of x dx is equal to Dirac delta nm, right? What is a Dirac delta function? Dirac delta nm value is equal to 1 if n is equal to m. Its value equal to 0 when n not equal to m. This is the value of Dirac delta function. Alright, that already we seen. Now look here, e raised to minus x. Okay, we can check. See, put n is equal to 0, m is equal to 0. Then Dirac delta 0 0 is 1, right? Because n is equal to m, right? N is equal to m. Then we are getting Dirac delta 0 0 is what? That is 1 because m is equal to n. Okay, here m is equal to n means its value is 1. Then this value is 1, right? Then integral 0 to infinity e raised to minus x L0 of x, m also 0, L0 of x dx equal to 1. This we are getting. We can prove this, we can verify, take LHS. Okay, what is LHS? LHS is equal to integral 0 to infinity e raised to minus x. What is L0 of x? We have already seen 1. What is L0 of x again? Again 1 dx. Now integral e raised to minus x is e raised to minus x divided by minus 1. Limit is 0 to infinity. That is minus of e raised to upper limit, that is e raised to minus infinity minus e raised to minus 0. Am I right? Alright. That is e raised to minus infinity what? E raised to minus infinity is 0. Right? Because e raised to minus infinity is equal to 1 by e raised to infinity. E raised to infinity is infinity, 1 by infinity 0. Right? Minus e raised to 0 what? That is 1. Then 1. Right? It is correct only. Right? We are getting. Now instead of that putting, you can put a delta m is n is 1, n is 0, m is 0. Then Dirac delta of m is equal to n means its value 1 by LHS is equal to now RHS, right? So this orthogonality relation also valid, right? Alright. Now recurrence relations also very important, right? Some examination previously asked, right? Some recurrence option A, B, C, D, different recurrence. Which is the recurrence relations corresponding to Leguerre differential equation? That was the question. Alright. Okay, we may expect a question like that. Alright. So we can do. Okay. So you have to by heart this recurrence relation. We can prove this, but you have to by heart it. Right? N plus 1 into ln plus 1 of x is equal to 2n plus 1 minus x into ln of x minus n ln minus 1 x. See, to prove this, see you can take this. Suppose n you can take 0 on either side, or n you can take 1 on either side. Okay, n you take 1 on either side, say then 2 into what? N is equal to you take 1, then L2 of x equal to n you take 1 means here 2 plus 1 3, then 3 minus x into here L1 of x, right? minus, right, n again take 1, then 1 into 1 minus 1 L0 of x. This is this. Now we can check LHS and RHS separately, we can find LHS first to find. What is LHS? 2 times L2 of x. What is L2 of x? 1 by 2 into x square minus 4x plus 2. That is what? 2 to cancel. That is x square minus 4x plus 2. Okay. Now RHS we can solve. RHS is what? RHS is equal to 3 minus x into, am I right? L1 of x you know value, that is minus x plus 1. L1 of x minus, what is L0 of x? L0 of x is 1 only, right? Now by expansion, what I can write? 3 into minus x minus 3x, 3 into 1 plus 3 minus plus x square and minus x, right? Minus x and here we have minus 1, right? All right. Okay. Now minus 3x, first x square. Okay. Now here minus 3x irukku, inge minus x, so minus 4x, right? Now here 3 minus 1 plus 2, right? Then x square minus 4x plus 2, x square minus 4x plus 2, right? LHS is equal to RHS, alright? Now another recurrence relation is x ln dash x, right? So let me take a pen. See, x Legurre polynomial differential, dash means first differential, first order differential, equal to n ln of x minus n ln minus 1 x, right? Put n is equal to 1 again, x is equal to, put n is equal to 1 here, L1 dash of x equal to L1 of x minus, put 1 L0 of x, right? So what is x into, what is L1 of x? See, d by dx of, that means d by dx of first order differential, L1 of x is minus x plus 1. This is LHS, right? That is x into minus x what? Minus 1 differential. 1 on differential 0. Then answer is minus x. Now let us do RHS. Am I right? RHS. L1 of x what? L1 of x is minus x plus 1. Right. And minus, what is L0 of x? 1. Then what is the answer? Minus x, 1 minus 1 is 0. Then minus x. Then LHS is equal to RHS. Alright? Alright. So like this, recurrence relations, these two recurrence relation, you should by heart. It is very important, right? Alright. Now, two questions given. What is L1 of 0? Next question is L1 of 0. That means, what is L1 of 0? 4 options given, right? L1 of 0, what is L1 of x? L1 of x is equal to minus x plus 1. Then what is L1 of 0? Minus 0 plus 1, that is 1. And option A is correct, right? Now L2 dash of 2, right? What is L2? L2 of x is equal to, what we studied? That is 1 by 2 into x square minus 4x plus 2. Now L2 dash of x is equal to differential of this, right? That is d by dx of 1 by 2 into x square minus 4x plus 2. That is 1 by 2 we taken out, x square on doing 2x minus 4. That is multiplying x minus 2, right? Now L2 dash of 2 they are asking, right? 2 means put x is equal to 2. Then 2 minus 2 is equal to what? 0. This also option A is correct, right? So this is all about Leguerre differential equation. Now next class we are going to discuss about a Legendre differential equation. Alright? Alright. Thank you.